Good morning. This is Mark Anderson speaking to you from Stillwater, Minnesota. And I'm going to explain how you can make the most from measuring counts in this webinar this morning, depending on where you're at. And we're going to show how Design Expert software tools for transformation and Poisson regression can really help you measure those counts more precisely. So let me start my presentation. And you can see me pictured there on the lower left corner. A lot of you know me from past presentations and encounters, but just to give you a quick idea of my background, it's professional chemical engineering and certified quality engineering. And it's the latter, the certified quality engineering, where I came across counts most often working on manufacturing process improvement. Oftentimes we were looking at defects, and it turns out that counts can be a very good measure for things like defects on a film or a coating, things like that. So we'll talk about counts. It's a pretty common measurement and how to make the most by using these tools with Design Expert. So again, welcome. And I just want to say, to make the most of this presentation, we'll keep you attendees on mute so that we eliminate the crosstalk and the voice over internet protocol reverberations and all that. You can go ahead and put in some questions on chat. Sherry Kraber, who's our workshop manager and a member of the consulting team, has volunteered to kind of watch out for chat that comes in. And I asked her, if it's important enough, feel free to jump in and interrupt me with the question. Otherwise, we'll wait till the end, and there should be plenty of time to answer some of the questions. I don't think the talk is going to go quite the full hour that we normally would. And then, of course, you always can send further questions to me directly, mark@staties.com, and feel free. I'd love to hear back from you. The presentation will be posted, the slides, along with hopefully a recording, to the webinar site on the Staties page. So you can always go back and look there. So far, we've got 33 attendees, and maybe a few more will be coming in. Let me know if you're out there by pressing the raise hand on your control panel. And just give me a hello. There you go. Sylvia, Susan, TK. I'm going up the line here just to check. Robert. Okay, so it looks like I've got more than a representative sample, indicating that I'm getting through to you and you're seeing the slides, I'm presuming, by that. So I'm going to go ahead and put the hands back down again, and we'll press ahead with our presentation. The first thing I want to mention is that I'm going to be demonstrating version 13 of Design Expert, which came out earlier this year. It's really exciting to see a major revision like this, and there's lots of great tools, like there always are when we come out with a new upgrade of the software. And we usually try to put in a mix of interface tools that add some pizzazz and make it easier to see things going on, and also hardcore statistical tools. So as always, we've got a lot of good things that we've provided. Now, if you're interested in getting a breakdown on that, go back to Martin Besener's demonstration of V13 that he gave back on February 17, and it's cutting edge tools. That's also posted to our webinar site. But you know, some of the things that are listed here are modified design space wizard, which is really wonderful for expanding, shrinking, or shifting the space and then filling in additional runs so that you can make use of things you've already done. It's a tremendous upgrade and took a lot of ingenuity by Martin and our programming team led by Hank Anderson. Import data set, that's something that I've been using quite often. In fact, even yesterday, I pulled in some data that was a combination of types of materials and the composition. So it was sort of a combined categorical mixture design, and I was able to quickly bring it in by pressing the import data set button. And I'll just toggle over to Design Expert to show you where that is. So there it is right there. You just press that import data and you're off and running through a copy and paste operation. That I've used quite a lot. Of course, the Poisson regression is something I'm going to be talking about today in detail, which is really good for precisely analyzing count data. I also will demonstrate this multiple analyses option, which I like a lot because you can look at different alternatives. So in this talk, I'm going to look at no transformation of count data. I'm going to look at using a square root transformation, and then of course the Poisson regression, which is under the special models part of the analysis. Boy, I tell you, all these are good. The next one, round columns, I've been looking for this for many years because oftentimes, especially with optimal designs, but even with central composite and standard designs, you get lots of decimal places. And being an engineer and a person working with DOE for so many years, I don't want to have to hit 10 decimal place settings. Now you can quickly round columns, and Martin provided a demonstration of that. And there's lots of other features. Again, go to the webinar site and pull up Martin's talk to get a good overview of all the different things that we have. But I'm going to focus on this Poisson regression in particular. So what I'll do is work through a series of different sections here to try to make my case for Poisson regression and the alternative, which is a square root transformation. So to begin with is, the prevalence of counts as a metric, and I'll list out some examples of that, some of the different alternatives and considerations for modeling counts. And then my demo will take the form of an experiment I ran on microwave popcorn, where I looked at the number or count of unpopped kernels. And the technical term for this is UPK. And I've done lots of experiments on popcorn. A lot of you may be familiar with this. And mainly in the past, I've always taken a weight of the popcorn. But once we got this Poisson regression tool, I realized I could do a lot better by counting. And I've got a really exciting outcome that I was able to produce using the Poisson regression. So then at the end, we'll conclude, and then there'll be some time, for some questions and answers, taking the form of you guys typing in chat. Possibly we could open up some of the microphones depending on how many people there are. Right now I've got 40, and that's where we run into some issues if we get too many people on the mic. So to begin with, let me talk about the case for counts as a metric. First of all, you're always, as a quality engineer or somebody working on manufacturing improvement or any type of experiment, going to do a lot better by counting things rather than just doing pass-fail. And the example we used to talk about back when we really were focusing on quality as kind of a nationwide initiative was looking at automobiles coming off the line. And, the old-fashioned quality control inspectors would just say that car is defective, and they would throw it off to the side. But a much more enlightened way of looking at something like that is to count the number of defects per car. Because there was a time, and I was around when this happened, when you would go to a car dealer and you'd get in the car and it was an American car, it was defective, and in many different ways. The door wouldn't close tight. You'd turn the radio on and the windshield wipers would go off and stuff like that. So doing a count will allow you to get a much more precise idea of what's going on. And ultimately, you need far fewer runs to do an experiment that would aim at trying to reduce the number of defects rather than just doing pass-fail. Now, we do have tools that came in with, I think, version 12 to handle this, and this would be the logistic regression tool, which would be another one of the special modeling tools. But you need lots and lots of runs if that's all you've got is pass and fail. So that's kind of my first point that I wanted to make. Then beyond that, it's just that counts are very common in different experiments. And these are some of the things I pulled up, but I could pull up many more examples. But Montgomery's book, Design and Analysis of Experiments, example 1.1 provides, a situation where you're counting the number of solder defects per electronic circuit board. So that's a common type of thing in electronics. My example from around the home here was the number of pulls trying to start a weed whacker. And that I wrote up in chapter 5 of DOE Simplified. Another one that you'll see in the tutorials is colony forming units for an antiseptic formulation. And that's something that you could follow up if you're interested in Poisson regression. And it's available in our help tutorials. And it's down here, this Poisson regression antiseptic tutorial. And this one, is looking at the CFUs or counts, and it gives you a good example of where the Poisson regression can give you a more precise fit. Another one that I came across way back when, I was working with a company that was making pre-baked pies down in Chicago, and all of a sudden there was this huge crisis during the actual class I was teaching, and it turned out that their customer, a hotel chain, noticed, it was a competitor that brought their attention to this, that if you flipped over our client's pies, on the bottom you would see pits or little holes, and there was a certain number of those per pie, and it turned out that handling that using the square root transformation was the key, and I was able to help the client see what it was that was actually causing the problems, and they solved the problem. Now, nowadays, I would certainly apply the new tool of Poisson regression. Another client was looking at fish eyes on a film, little imperfections, and so they would, pull off the film, and they would get an appropriate amount of film that would have some, measurable count, and then they were able to change the composition of that film and solve that problem. Completely off the beaten path of industrial experimentation, which is our niche, of course, would be hits on a web page. And I had actually an experiment that was similar, where we were sending out postcards and we wanted to see how many people responded. That was a count. And so that's a really good example of where counts come into play. And there's many more. Now, let me just ask you, as kind of a quick survey, raise your hand if you've ever worked with counts as a measure. Go ahead and press that raise hand button just to see if any of you have ever used counts. And I've got Arvid, of course, who is one of the top quality guys in the whole world, raising his hand, and a number of other people are also giving me some feedback. Greg, Jim, James, a lot of especially the people that are working in the quality field and in the field of statistics, have seen this happen quite often. So thank you for that feedback. I'll go ahead and put the hands back down again. All right, so hopefully I'm setting up the what's in it for you, or the WIFM, what's in it for me, that counts are something that you really want to pay close attention to, using as a metric, and also then how are we going to analyze that a little bit differently because of the differences that counts take over normal continuous responses. So here are some of the considerations that are worth discussing. First of all, the attributes of counts is that they're discrete whole numbers. There's no upper bound, and they're not continuous. And given all that, then you'll find that these counts are not normally distributed by the bell-shaped curve, but rather they take a distribution called the Poisson distribution. Poisson is kind of a funny word, and I think in French it actually also means fish. And I'm giving it kind of a French presentation as Poisson, but I've also heard people say Poisson, and maybe some people might say poison because they just don't want to have anything to do with it. But I naturally pronounce this Poisson, but however you want to call it, it's something different than a normal bell-shaped curve. It actually tails off to the right because 0, of course, is a boundary, and the closer it gets to 0, the more that it's going to be non-normal. Now, interestingly enough, and I discovered this many years ago in reading history of statistics, that this guy Ladislaus Bortkiewicz was one of the first to really make use of this Poisson distribution, and even they thought it should be called the Bortkiewicz distribution. But I guess I'm going to say Poisson, maybe a little easier than Bortkiewicz. But what he discovered was that the number of Prussian cavalry that were killed by their horses between 1875 and 1894 followed this non-normal distribution, and he wrote this up in this book, The Law of Small Numbers, in 1898. So I find that kind of a gruesome example, but it's memorable, and it actually was pretty historic as one of the early applications of this non-normal distribution. Now, as far as dealing with this non-normality, the standard workaround is to take the square root transformation, and then you can just use ordinary least squares regression. And as I've had a chance to work with the new Poisson regression tool, which is a generalized linear model or GLM application, I'm actually finding that the square root transformation holds up pretty well. And for me, it's a little bit simpler to contend with in some regards than the Poisson regression. Nevertheless, I do think it's well worthwhile to try both the square root and the Poisson regression, and then kind of go with whichever model you think is going to work for you best. In some cases, I think the square root transformation may not be too bad, and possibly it might be a little bit simpler for people to contend with. However, I have run across situations where even a square root is a little bit daunting for people. But if they're being thrown off by that, then the whole deal is going to be tough. And maybe they should just have somebody present the data to them and don't let them try to do it themselves. But I think for most people, they'll find the square root a little bit easier to contend with. So let's look at examples of that and do a comparative study on the popcorn. And I'll be coming to that in just a minute. However, I've got a few other considerations regarding counts and Poisson regression in particular. One thing is that it really should be a relatively rare event, and we want to be sure to have a fixed area of opportunity. And what do I mean by that? Well, for example, going back to the fisheyes on a film, of course, we want to make sure that every time we reset our machine up and see if we can get it to generate differing amounts of counts and learn something from that in a planned experiment, we're going to want to look at the same area of the film. So you would probably have a light table, it would have a certain area on it, and you would put the same square feet of film on that light table, and somebody would carefully look it over, or maybe you have a machine doing the count. You don't want to change that area from one run to the next. It's kind of obvious, but we want to make sure that that's clear, that that's how we're going to do it. The need for the special handling will be reduced as the number goes up. And you can see from the series of curves here that I took out of Wikipedia, how as the count goes up, the distribution becomes normal. And what I saw as kind of a general rule is that if the mean count is greater than 20, you might get by with a normal approximation. Now keep in mind, full disclosure, I am not a statistician. I would consider myself to be a professional experimentalist, if that's even a word. But my background is strictly engineering, but I've done lots and lots of experiments, of course, over the decades. But that's what my understanding is that once you get above a mean of 20, yeah, maybe you could just use the normal curve. I also discovered, as I was digging into this Poisson regression, that there's a problem of what they call, quote unquote, too many zeros. Unfortunately, I wasn't able to find out exactly how many zeros is too many. So far, I have not come up with that, just that there's a problem if you have too many. So what you can do, from an engineering perspective, is you can establish your sample size or your area of opportunity so that you get, plenty of counts and you don't have too many zeros in your data. So that was something that I was always doing anyways, even before I realized that the statisticians were talking about this quote unquote too many zeros. Then, of course, as the statisticians know, and a little bit of research will tell anybody digging into this, that this Poisson model restricts the mean and the variance to be the same. And it turns out there's a problem of what's called quote unquote over dispersion. What does that mean? I'm not exactly sure, but from what I understand from this book by Abraham and Ledholder, that there could be other impacts on variability than what normally would come in on the Poisson model. And interestingly enough, they recommend this square root transformation as a way to kind of work around this little problem of over dispersion. So I don't know when you're going to hit this, but I do know that it's easy enough with Design Expert to try the square root as opposed to the Poisson, and then you can, basically kind of go with whatever model works best. And along the lines of George Box, that all models are wrong, but some are useful, I feel pretty unconstrained to go ahead and try different models and just kind of go with whatever one that seems to work the best. So at this point, I'm just going to stop for a second and just check if anybody has any questions. I'm taking a look at the chat, and Sherry is watching this as well. So I don't see any questions just yet, but maybe you're holding off on them to come in at the end. If you're with me so far and you don't see anything too objectionable, go ahead and press the raise hand button. Okay, and Alan coming down from the top and going down to the bottom, Wenyu and Yun. Thank you. So in between, there's lots of other hands up, so I appreciate that feedback. And so let me continue on with my little talk about counts. Okay, so here's the fun part, at least for me. During the Christmas holidays, being more or less quarantined now for practically a whole year, I do have, as a over 65, my first Pfizer shot, but I am waiting for the second one in a couple of weeks, so I'm not quite ready to venture too far. But fortunately, we have kind of a quarantine going here with the Anderson household, and I kind of like that, quarantine. And I'm able to work with my grandchildren, a number of which are doing homeschooling as part of the distance-based deal that we've been into this fall. My wife is a preschool teacher, so it's been very interesting. So I've taken the opportunity to do some experiments with my oldest grandson, Archer. We just finished Archer's Big Bounce experiment, which you can see on my Stats Made Easy blog, and did a little video and sent it into the University of Minnesota Athletic Department, looking at different size basketballs and things like that. Another experiment that I did over the Christmas holidays is this one on microwave popcorn, and Archer helped me with that. And what got me going on it to begin with was I came across this app that allows you to listen to the number of pops. It's called Popcorn Expert, and it actually works pretty well, and it gives you a cool little graph. And once it hears that the pops are several seconds apart, it sets off an alarm and you know to turn off the microwave. Now, the reason that I decided to do that is because the grandkids have been very happy for me to pop off, a number of bags for them every afternoon. And I noticed that the number of unpopped kernels was running quite a bit higher than I would have thought. And so I thought, well, maybe my General Electric microwave is beginning to wear down. It's about 15 years old, and it has a popcorn button on it, but that popcorn button wasn't really working. So I tried a little range finding experiment with Popcorn Expert, and lo and behold, the Popcorn Expert told me to run the microwave a little bit longer, and I was able to get popcorn before it burnt that had a lot less UPK. So the next thing is that led me to looking at the manual, which I never had done in 15 years, typical engineer. And I found out that they made a provision for that where you can press the 9 key and get 2 extra pluses for a total of 30 seconds. The first time you press 9, you get a plus on 20 seconds. And the second time gives you 10 more seconds. And I discovered that that worked pretty well, and it was easier than using the Popcorn Expert, because when I use this app, I would have to set the phone right by the microwave and tell everybody in the house to be quiet, which was upwards of 6 grandchildren, and that was, not working too well. So what I did is I set up an experiment, and actually to make it more interesting, I went back to something I've tried before, which is preheating the microwave chamber with 1 cup of water for 1 minute. And this is something that's a hack. And even the Popcorn Expert says, did you know that adding a bit of water to the popcorn will make it softer? Well, it's not quite that, but it's putting in water to try to preheat the chamber. So there's different things you could try. So I thought I would try that. And then I made 3 different options on the timing. One is using the GE default, just pressing the popcorn button. The second one is pressing the popcorn button and then quickly pressing 9 to get plus on the time. And then the third, of course, is using this popcorn expert. Now this makes a 2x3 factorial, which is a multi-categorical design. It's an option in Design Expert. In the end, I was able to make a huge breakthrough. So let me explain what happened. Before I do, a little bit of an aside, learning by accident. And this is the importance of doing pre-experimental research and testing. So one of the other hacks that I learned about was that if you put the popcorn into a covered glass bowl, supposedly you would get a better yield. So I tried that. Well, that failed completely. I got this very alarming sensor error. And I thought, darn, I've broken the microwave. But when I went back and read the manual for the first time in 15 years, I realized that with a little bit of extra research on the internet, that my General Electric space maker uses humidity to time the popcorn. So that was a unexpected thing because I thought the microwave was listening to the popcorn. What did I know? And when I put the plastic cover on it, the moisture couldn't escape. So oops. If I was going to try this again, I would use a perforated lid. So that's where I found out, reading the manual, that, hey, I could actually press the 9 key twice and get more time. And that turned out to be the key. So it's funny how you learn by accident sometimes, if you're paying attention. But maybe I could have learned that, 15 years ago if I would have read the manual, but oh well. Let me just do a quick survey just to see if anybody else is like me. How many of you just go ahead and start using a microwave or any other process without first reading the manual? Is anybody going to confess to that? Okay, so a few other people are raising their hands, so maybe I'm not the only one. I don't know why that is, but I think it's just because you feel like if you just start playing with the machine a little bit, like my new electric snowblower that I bought before this year, it seems like sometimes you learn a little bit more on your own by mistakes, as long as you don't blow yourself up or do something really stupid like I did with the snowblower. I thought, I wonder what's going to happen if I take the snowblower and run it over the front mat out on my steps. And that was not such a good idea. I probably should have read the manual on the snowblower before I tried that. Anyways, back to the popcorn. Once I had gone through this little process here of understanding a little bit more about how the microwave worked, I was ready to rock and roll. And this is the result that I'm so excited about. And I'll pull up the software and show you this, but it turns out that by using the Poisson regression, which fits things more precisely for counts, I was able to see this little interaction between the preheating of the water, yes or no, and the 3 different types of timing. And you can see it here where these bars are slightly separated. Believe it or not, these are called LSD bars, least significant difference. And when they are separated like this, it means that there's a significant difference in this combination here of no preheat, which is this square button here, and the green triangle, which is preheating. There's a separation, and that's illuminating because on the left-hand side, I've got the response, the Y, and we want that to be minimized, of course. We want fewer counts, right? And what happens is if I switch from what I had been doing with the built-in button of GE and go to the GE++, I'm able to get just about as good or even better than what I got with the Popcorn Expert app, but a lot more conveniently, because all I got to do is quickly hit that 9 key twice. And what I think is happening is with the water preheat, because of the humidity sensor, it's actually better not to use that water preheat, right? And furthermore, by not using it, I save 1 minute of time. So I'm saving 1 minute of time by not preheating, and I'm getting a popcorn yield that's much higher than what I had gotten before. So this was very exciting to me and gratifying, because that meant when I gave the grandkids, their bags of popcorn, there was a little bit left over for Papa to have as well. So let me go over to the Design Expert program, and I'm going to just start from scratch here. And I'm going to open up the popcorn file. And then I'm going to do Control mouse wheel to expand the size of it. Okay, just to make sure that I'm on track, look at the comments here, and do you see some of the things like Vienna helped? Press the raise hand if you're seeing that, and I'll explain what that means. Okay, getting a good sampling of people raising their hand. Thank you for participating on that. So back to what that's all about. Well, Vienna is, well, one of the younger grandchildren. I think she's 2 years old or maybe 3 now. I'm kind of losing track. So she wanted to help along with Archer. She pulls her chair over and stands up there right next to me. And my comment is that she helped, but it's just that she was distracting me. And I had other types of distractions going on here, and just flat out mistakes. So this is full disclosure with these comments, and it's very important. I learned this straight away as an R&D guy to always, write down what's happening as you're doing your experiment. And this may help you in the end to interpret, possibly some results that didn't come out quite the way you expected. So this is a nice little feature of Design Expert to put these comments in. Now, the way I built this up originally, the way I planned it, I'll show you that. And let's see, let's go vertical on this. So this is under multi-level categoric. And because I've only got 2 factors, it's vital that it be replicated. And otherwise you can't develop any testing for the 2-factor interaction if it's unreplicated. So 2 replicates is required, for that reason. And then the other question you need to ask yourself is this going to be powerful enough to see the difference that you're hoping to detect? And that comes in our power calculation here. And I think I was running at about, 60 unpopped kernels, something like that. So even, a difference of 10, if I could reduce it by 10, that would be important to me. And so you kind of arbitrarily have to put in, what your objective is at a minimum to see a difference. I'm just gonna throw that in. I did the experiment already, so it doesn't really matter at this point. But then if I was to do a series of popcorns over and over, I think probably the standard deviation might be, somewhere around 5. And this tells you something about, what your power is likely to be. And what's interesting here is that because the A factor has only got 2 levels, either no preheat or yes preheat, whereas the B factor has 3 levels or 3 categories, you see a difference in the power between the 2. So arguably, I could have set this up with more replicates, but I figured I could always do more replicates and then block, later, and I wanted to get on with the experiment. So I went ahead and set it up with just 2 replicates. And you'll see that from the results, I was able to get significant outcome, although part of it is that I ended up doing more runs than what I had originally planned, and that gave me a little bit more power too. So if anybody has any questions about my design of experiments and the actual application of the experiment, go ahead and throw in a chat if you would like, and Sherry can always break in on me if I need to answer a question at this point. So now that I've got the data, you're probably kind of interested to see what happened. Now, the first thing that I always do, and I teach this to my students, is I just do the intraocular test, as Montgomery calls it. As Yogi Berra said, you can see a lot just by looking. So why not just look at the raw data? But it makes it easier if you sort it. And what I'm seeing here is that, there's a fairly broad range of count, which means, probably something significant occurred. more than the changes more than what I would have expected, and you could do some calculations on that, especially being likely to be a Poisson distribution. But I don't want to overanalyze things. Another thing I notice is that I don't have the problem of too many zeros, which maybe I would have had if I would have burnt the heck out of the popcorn, so there was no UPKs. One time I watched a Simpson episode on making popcorn, and Homer takes the bag of popcorn and puts it on the nuclear pile. That's one way not to get any unpopped kernels. Now, another thing you can do is you can use graph columns. I always recommend that. Now, these are categorical factors, so we've got an X instead of the normal color coding that we would see, and there's no correlation provided. Our PhD, Martin, when he started, made us turn that off because he said, whether you put yes on the left side or yes on the right side is completely arbitrary. But you can look at the graph, and it's a little bit uncertain looking at the effect of preheat if that actually had an effect. As you know, there was an interaction, so that's part of the problem of looking at just main effect graphs. But then looking at the timing, we do get the picture of how the original GE popcorn button isn't really working the way that we would like, and it could be changes in the popcorn over the years. For example, I noticed nowadays the simply popping corn I use only has 3 ounces in it, and originally back in the day you would get 3.5 ounces. So I think the food manufacturers are playing tricks on us by making us pay the same amount for lesser amount in the bag. Do you think that could happen? I could take a little survey, but I think most people would raise their hand and realize that the food manufacturers keep shrinking the amount, but not the price. So maybe that's part of the problem. Okay, so that's enough looking at the graphs. Now, the first thing is, let's look at the as is. Now, when you start your analysis now with version 13, you're going to see a little different setup. I'm going to add one more analysis to demonstrate this. This is not a real analysis, but notice how there's no tabs coming across the top. So the version 13 requires you press this start analysis to begin with. And then you get the normal tabs across the top. Now, let's go back to one that I already analyzed, and this is using no transform. And actually, only one thing pops off, and you saw this, when I did the new analysis. It's really only picking the main effect of B. But what I wanted to do for comparison purposes is go ahead and pick all 3 effects that you can estimate. So I actually went over to this right-hand side for numeric, and I'll clear this. And what I did is I just double-clicked all 3 effects that you can estimate and left these other as error estimation, which are the replicates, which are the green triangles. Now, I know this is not the right way of going about things, because when you go to the analysis of variance, of course, you're going to see that the effects that were on the line with the green triangles are not significant with the p-value. But bear with me, because I want to compare, what I see with what happens with the square root and the Poisson regression. Now, the diagnostics are showing, abnormalities, which is not surprising. On the normal plot and also on residual versus predicted, you get this increase in variation, which is characteristic of counts. The higher the count is, of course, the more variation you're going to see. And that's a direct connection with the Poisson distribution. But never mind that. Looking at the interaction plot, of course, you don't see any, characteristic interaction. Let's put the timing on the bottom by changing that to the X1 axis. And there's an overlap here all the way across. So we're not really seeing that the effective timing depends on the preheat with the as is. All right, well, we saw in the diagnostics, some indication there's not quite enough power here to show this, but that we want to move off where we're currently at, somewhere off to the left, probably the square root. So I did that next. And again, I went ahead and picked all 3, but it didn't do much better than the as-is transformation. Still, not really getting, it's a better pattern of residuals than before, but still not that great. And I'm not seeing the separation. The effective timing does not depend on the preheat. So, all right, well, I was making progress because I could see that the GE++ definitely was doing better. But the real revelation came when I went to the special models here. And now Design Expert can detect that you have counts, they're whole numbers, they're above 0, and it automatically, gives you this special model once you click the special model of Poisson. Similarly, if you had just zeros or ones, it would point you in the direction of logistic regression. Now, when I do this, I'm not going to get the same normal plotting and other diagnostic graphs that I get with the ordinary least squares. It's just not developed or invented yet. And there's, funny things happening here with the GLM. It's actually doing a log of the responses and so forth and so on. You don't get the standard F values and things like that. But luckily enough, there's ways to approximate the P values, and we're getting, closer to significance on the AB. And honestly, I did some cherry picking on that, I admit it. So the PhD statisticians and masters in the audience might take me to task on this, but I figure as an engineer, whatever, leads me in the right direction, I'm going to use it. The R-squared values are approximated, but you can do some work to compare the R-squareds that we see here with, for example, what we would see here, bearing in mind that I'm using a model that's not very good. So there's different things you can do, but I'll show you one way that I like and Martin approves. If you go to the point prediction and you compare the standard deviations of the different models, is kind of a good bottom line. So as is and square root, there's not much of a difference. But when we went to the Poisson regression, I was able to get that standard deviation reduced by half of what it was before. So I think that's probably a pretty good indication that the Poisson regression actually works pretty well. I don't have too many zeros. I don't have a really large value of counts where you get over dispersion issues. And so I'm kind of in a sweet spot for the Poisson, I think, with this popcorn example. And then this is where I was really excited to see that I could switch to the GE++, don't have to use the app and all the issues of getting the whole house of grandchildren quieted, getting the phone up by the popcorn machine and all that bother. I just simply need to be quick at jabbing 9 twice. I don't need to put the glass of water in and just, let her go, and boom, boom, boom. Now I've made dozens and dozens of popcorns for the grandkids with only, maybe 10 UPKs left in the bag, and plenty for Papa to eat. So I would consider that to be a tremendous success. Now, maybe I'm, being a little bit overly enthusiastic, but if you agree that this is, pretty impressive success with the popcorn machine, give me, a little bit of positive reinforcement by raising your hand if you think that's pretty good. All right, thank you for that. I need a lot of positive reinforcement, especially nowadays, being stuck here at home at my desk and nobody's around to give me that attaboy. So that's basically my presentation. So to conclude, I just want to say that I really do like counts. They serve well as a response measure, and certainly they're far better than the binary pass-fail. My tip for you, if you're using counts, is to be careful in terms of what your area of opportunity or sample size essentially is for your experiment, and try to expand that so that it doesn't come out at 0 very often. And generally speaking, that can be done fairly easily. Like on the circuit board example, you could look at 10 circuit boards per run and count up how many solder defects are on that. You don't have to do just one circuit board, or the area of the film that you're looking for the fisheyes or whatever. So expand that, do a little bit of quality engineering on that before you start. And then you can do several ways of modeling. It's really easy with Design Expert nowadays. Design Expert 13 really works well for doing these multiple models. And why not try no transformation to keep it simple statistically, but then definitely try the square root and then apply the Poisson regression. Why not try it? And then compare how they fit and then go with whichever one is most useful, whatever model works best for you. You do have to watch out. I've seen this happen, for example, with the antiseptic case. Somebody typed in the data one number that had a decimal place, and I kept trying to get the Poisson special model to work, and it never worked. And I almost wrote that up as a bug, and finally I discovered it before I embarrassed myself that there was a typo. So always watch out for that. That's personal experience. Now, I have to admit I remain a few kernels short of the perfect microwave popcorn. And some people might say mentally, I'm a few kernels short. But my wife, for example, might say that from time to time when I do these crazy experiments. But I do like, doing microwave popcorn experiments. I would just suggest that you try to be safe. Don't do stuff like I did where you put the popcorn in a covered bowl when there's a humidity sensor, because you might destroy the microwave. I've also seen a lot of people do way too long of a time, well, myself included. When I did my first microwave experiment with the microwave that I burnt up, I went way too long and I created what I called the clinker, which was like a piece of coal of popcorn that it burnt. So be careful, especially with microwave popcorn, with any type of experiment, to do pre-experimental range finding. Well, now that Design Expert provides these great tools for counts, I'm certain that I'm going to do more popcorn experiments. And this time around, I'm going to count the unpopped kernels. It's much more precise, and it fits a lot better using the Poisson regression. So give that a try. Give version 13 a try. I really encourage you to do that. I think you're going to like it. Now, if you're interested in learning more about design of experiments, there's a lot of opportunity from Staties. We do various webinars from time to time. Mainly Sherry is doing this crash course for experimenters. And I think, Sherry, if you want to jump in at this point, if you're still there, let the group know when you might be doing another one of those crash courses.
Hi, Mark. I am here. My crash course is actually next Wednesday, March 17th. So it's coming up. And then the new user intro is on March 31st.
Okay.
There are a couple of questions, Mark. If you would just go to the very end of the questions, you'll see the last couple from Margaret and Yun.
Okay, I'll check that out. But before I get off the training, you can go to our website and you'll see, lots of opportunities coming up with more of a workshop type environment. There's a 5-session modern DOE for process optimization. We've had a lot of private presentations of that as well. And so that's something you can get by contacting our workshops, which Sherry and her team will follow up on. Mixture design, which is one of my favorite tools, being from the chemical industry, is a regular class for optimal formulations. Again, that can be done privately. And then strictly on a team basis, Sherry and the workshops group will work with you to set up a class that might be a little bit more tailored for your particular industry, whether it's pharma or food or whatever. And Sherry, any other comments about the training?
Nope.
Okay, so let's take a look at the chat here. For some reason, I'm not seeing what's under the questions. Okay, I've got it. Thanks for the webinar. You're welcome, Arvid. Let's see if I can pull that out. All right, I got this popped out now. And Jim has left, but he said that he had a great project with the plywood company looking at defects. That sounds like a good example for counts. Arvid has gone off, but are the power calculations affected by the fact you're doing a logistic regression or transforming the response? Yeah, that's something that I'm probably going to go back and, along with some of the other questions, and ask our team, our statisticians, what they think about that. Would the amount of unpopped kernels be proportional to the amount of kernels in the bag originally? Yes, that's certainly something to consider. UPK versus timing color by preheat can show the interaction. Yes, on the graph columns, Arvid is correct. I've oftentimes used coloring. Can Mark show again how to compare fits using point predictions? Okay, that I can pull back up, and under the point prediction, what I learned from Martin, I'm gonna go to a single pane here, is that if we look at the standard deviation, you can compare directly, between the different models because it's in the units of measure. So hopefully that addresses the question Margaret had. I think that's the simplest way of comparing the different models, but there's lots of other ways, including the pseudo R squared values and p values and diagnostics, and there's a ton of different things that you could look at to decide, which model is best. But the standard deviation is kind of a nice little bottom line. If using least square model for count data, would box Cox plot automatically recognize and recommend box square root transformation? Yes, normally I would expect that the box Cox would have said go to the square root, but for some reason this particular data set didn't, actually recommend it. Part of it is that the power of the experiment was fairly low, and so the red lines that are formed on the box Cox, which is here, did not, show a significant advantage to moving from the current transformation to a different type of transformation. But I was moving in the right direction with the square root. You can see that on the right red line and where the blue line is, that we've reduced the log of the residual sum of squares. So that seemed to be moving in the right direction, but it didn't significantly recommend it. So that was what I oftentimes will call an artifact of the particular data. So that didn't in this case show me that I wanted to move, but nevertheless, I think it was indicated. Zero inflated Poisson regression. Arvid, before he left, was mentioning that. He said he will pass the thought on to Martin. That's good. Yeah, Martin would have to consider that. Oh, okay. So I guess Arvid was still on here. The pure error was so large. Yeah, good point. Okay, Arvid, thank you for that. And unless there's any other questions, then I'd like to say thank you for the group for attending. And I did leave my email on there, so be sure to get back to me if you have any other questions. Feel free to address them to mark@stateast.com. Well, thank you, everybody, and thank you, Sherry, for helping out. And take care now and have a great day. Bye-bye.